Okay, question 3. We've got an integration. First thing to notice is there's an x term under the fraction, so we need to move that before we can integrate. We bring it up by making it negative, so we're trying to integrate 6x to the minus 3 with respect to x. We're just going to use the basic rule of integration. We increase the power by 1 and we divide by that new power. It's an indefinite integral, so we must remember a constant of integration. Now we're going to simplify. 6 over minus 2 is minus 3. Our x to the minus 2 can be moved down to make it x squared. And again, remembering our constant. So the answer is negative 3 over x squared plus c. Okay, question 4. Calculate the shaded area shown in the diagram. It's an integration question. The limits can be found just by looking at the diagram. We're trying to find the area under the curve and above the x-axis, so we just use the 2 points of intersection, which are 0 and 3. We're integrating the curve itself, which is x cubed times 3 minus x. With respect to x, we can't integrate without first multiplying out the brackets. So we're going to multiply x cubed by each term in the brackets, which gives us a new expression of 3x cubed minus x to the power of 4. Now we can integrate. We integrate each term in turn, increase the power by 1 and divide by the new power. So 3x to the power of 4 over 4 minus x to the power of 5 over 5. Because we've integrated now, we lose the integration sign and we have squared brackets. We need to still have our limits there at 3 and 0. Now we're going to substitute in. Don't try to do too many steps at once here. We're simply replacing every x with a 3. So 3 times 3 to the power of 4 over 4 minus 3 to the power of 5 over 5. Because we're at the substitution stage, we're rounded brackets now. We're taking away using the lower limit, which is 0, but that actually gives us an answer of 0. So we can leave that at this stage. Now, in a NAB you do have a calculator available. I wouldn't advise taking the whole thing in the calculator at the moment. Just look at the tops and bottoms of the fractions so you can still leave your answer as a fraction rather than a decimal. So 3 times 3 to the power of 4 is actually 3 to the power of 5, which is 243. So we've got 243 quarters. Take away 243 fifths. Because they're fractions, we need a common denominator. So we're going to choose 20ths, and we're going to have 1,215. Take away 972 20ths, which gives us 243 20ths, and that is 12 and 3/20ths, and that's units squared. Okay, question 5. This time we're writing down an integral to represent the shaded area. There's a line and a curve. In order to find our limits, we need to first find the points of intersection between the line and the curve. And we do that by equating the line and the curve. So we've got x squared minus 5x minus 3 is equal to 2x minus 3. We're going to move everything to the left hand side. So we get x squared minus 7x equals 0. Now we factorise. That's a common factor of x. X times x minus 7 equals 0. So the two values that x can take on are 0 or 7. At this point, just double check on your diagram that makes sense. You can see that x is 0 on the first one there, that's our lower limit, and 7 is our upper limit. Now we need to decide what it is we're going to integrate, and it's important that we know what's on top, the curve or the line. In this case, the line is on top. So it's going to be 2x minus 3, which is the equation of the line, take away x squared minus 5x minus 3, which is the equation of the curve, and all of that with respect to x. We're going to just tidy that up now. So the limits are 7 and 0, and I've got 7x, take away x squared, and the 3's cancel out, so that's it with respect to x. We don't have to carry out the integration for this question. So that's our final answer.